Alright, now we have talked about this form a to the m over n in the exponential form. Let's go ahead and talk about it in the radical form. By the radical form, we of course mean putting it with the radical sign on it. So again, if all your indicated roots are real numbers, your expression a to the m over n, you can write it as nth root of a to the m power, where you are first taking a to the m, and then whatever answer you get, you take the nth root, or take the root first, okay, nth root of a, and then whatever answer you get, go ahead and then find the exponent m. So again, you can see we're breaking it up into two different methods here. So let's go ahead and take a look at these examples here. Now all we are doing here is basically just converting between the radicals and rational exponents. So if you have 3 to the 1/2 in the radical form, you would write it as square root of 3. Okay? 8 to the 3/4 in the radical form, you will see that n, which is your denominator on your exponent, is the index, and then m, which is numerator of your exponent, is the power. Okay? So if you had to write 8 to the 3/4, you could write this as 4th root of 8 cubed, or if you choose to, you can write this as 4th root of 8 and then the whole thing to the 3rd power. Okay? As long as you remember that the denominator becomes the index and the numerator becomes the exponent. Okay, we'll look at a couple more examples just to convert between radicals and rational exponents here. Right, so let's say we have something like this. Now here you will see that you have two expressions that you are subtracting. So let's go ahead and work on the first one, 9q and the whole thing to the 5/8 power. So you can write this as 8th root of 9q, and then if you want, you can put the 5 on the outside. Okay, so again, denominator becomes the index, numerator becomes the power, and minus. For the other term, you have 2x to the 2/3. So again, you can write this as cube root of 2x and the whole thing to the 2nd power. Okay, and this is how far you can go. You cannot simplify this any further, so I'd go ahead and leave it at this form. Okay. Alright, let's go ahead and take a look at this example. This one is with a negative exponent. So the first thing we will do is make it a positive exponent. Since you have 2m to the negative 3/2, put it in the denominator, 1 over 2m, and the whole thing to the 3/2. Since the negative exponent was on the whole thing, when you make it a positive exponent, it still has to go on 2 and m together. Alright, now that you have made it into a positive exponent, let's go ahead and write this as a radical, which will give us 1 over, and since 2 is in the denominator, so that tells us this is going to be square root of 2m, and then the whole thing to the 3rd power. Okay? Alrighty. Now you have seen how to convert rational exponents into radicals. Now here we're trying to go the other way around. They're giving us the radicals and you want to convert these into rational exponents, and since these are numbers, you want to try and see if you can simplify it any further than that. So if you have square root of 5 to the 10th power, again remember, when you are working with radicals and rational exponents, whatever is the index of your radical becomes the denominator, and whatever power you have will become the numerator of your rational exponent. So how will that work with this example here? You can see that you have 5 as your base, 10 is your power, so that will become the numerator, and the index of your radical will become the denominator. Since this is a square root, that tells you your denominator is going to be a 2. Okay? So again, index of the radical will become the denominator, and the power will become the numerator. Now, since you have 10 over 2, you can reduce that down, and 10 over 2 will basically be the fifth power, right? 10 over 2, 10 will go into 2 twice. And go ahead and evaluate and see what you end up with, 5 to the fifth power. And you should be able to come up with some answer here. So go ahead and see what you end up with for that. Alright, let's look at this example here. Now you have 4th root of 6 to the 8. So again, the first thing you will do is go ahead and convert this into a rational exponent. So that will give you 6 as your base. Okay, and then the power will become the numerator. The index will become the denominator. So again, you will end up with 8 over 4 as your rational exponent. And go ahead and reduce the 8 over 4. So 8 will go into 4 twice. So that will give you 2 as your power. And then again, go ahead and evaluate and see what you end up with for 6 squared. And of course, you know that will be 36 as your answer. Okay, just a couple more examples. And let's see what we end up with. Now, in this example, the first one, you have, of course, you can see these are all in terms of variables. You have 4th root of w to the 3rd, and this expression is being divided by the 6th root of w. So let's go ahead and try and simplify this. Now, you can start by writing these into the rational exponents. And for the numerator, you have w. Power is 3, the index is 4. So you can end up with 3 over 4 for this rational exponent. For your denominator, you have the 6th root of w, so that will be, of course, your base of w. Now, since you don't have a power here, it's understood that it's going to be 1, and the index is 6, so that becomes your denominator. Okay? Now, if you guys remember when we talked about rules of exponents, you must have seen that in an earlier class. Anytime you have the same base on your rational exponents, you go ahead and subtract the powers whenever you're dividing them. So since we're dividing w by a w with different exponents, to solve this expression, you will go ahead and take the base and subtract your exponents. Okay, so you'll end up with 3/4 minus 1/6. Now, anytime you're dealing with fractions, you know you have to have the same denominator before you can start adding or subtracting them. So since you can see you have 4 and 6 as your denominators here, go ahead and find your least common denominator between 4 and 6, which of course will be 12. And then rewrite each one of these fractions with a denominator of 12. So that should give you w. And then if you write 3/4 with a denominator of 12, you will end up with 9/12 because you'll have to multiply the whole expression by 3. 4 3s are 12, 3 3s are 9. And for 1/6, to have a denominator of 12, you will multiply the whole expression by 2. 6 times 2 is 12, and then 1 times 2, of course, is 2. Now you can see that since you have the same denominator, you can go ahead and subtract your numerators. 9 minus 2 will give you 7. And w to the 7/12 will be the solution to this expression here. So you have to try and apply, since you are talking in terms of rational exponents, you have to apply all the rules of exponents that apply to any exponents will apply to rational exponents as well. All right, one more example and then we'll move on. Now here you have square root of r to the 50. So the first thing you will do is rewrite this as a rational exponent. Since your power is 50 here, that will become the numerator. You're talking about square root, so your index is 2. That becomes your denominator. You can go ahead and reduce 50 over 2. 2 will divide 50 25 times, so you will end up with r to the 25th, and you cannot go any further from there, so you just stop right here, and this will be your solution, r to the 25th. So you should be able to comfortably go back and forth between the rational exponent form or the radical form for expressions like these.